Okay, I hate it when I do what I did today in class. When I start because I just think, oh, I can solve any of these without really having to think about them. Well, this one you actually had to think about, but it was a classic science thing that we do. So here's the problem. Now here's one of the about 5 minutes after y'all left, I sat there and worked on it and went, oh yeah, well this is the clue to it, and then I solved it, But I was like, you dumbass. Anyway, so so and it's a classic science thing that happens. It's a classic science thing that happens. What we do is, if because a lot of times we come up with two unknowns and only one equation, and so we have to take another measurement using a different variance. No, but we know that the two unknowns are constants, that they are not changing. And in this case, the distance between the slits, D, is not changing. And the, let me turn on the ladybug here because I'm going to show that to you. The distance D on the slits is not changing. And the, any day, and the distance to the screen is not changing. Okay, so those two things are physical attributes of the problem that are not going to be changed. So, and they told us that the sine of theta is approximately equal to the tangent of theta. So that's good news. All right, so here we are. Okay, and they go, okay, well, the separation distance y2 between the second order bright fringe and the central bright fringe on a flat screen is 0.015. Okay, so we know y2 on the first one. I'm going to say y2 is equal to, you'll see my work here in a minute, 0.0152 meters. Okay, cool. That's fine. And then when the light has wavelength, okay, so lambda 1. So for lambda 1 that we're going to be doing, the y2 for lambda 1 is equal to, and then this is 425 nanometers. Okay, and then it goes on and says, assume that the angles are small enough so that we can use, the tangent thing. Find the separation y when the light, find the separation y. In other words, we'll find when the light has a wavelength of 571. Okay, so we're going to find y2 prime here. Okay, so y2 prime we don't know. All right, now let me show you what we're working on here. Okay, y2 prime, I don't know. Distance to the actual length to the screen, I don't know. But I do know this. And so y2, well, let's just call it y22 instead of y2 prime. All right. So I do know y21, and I know the initial wavelength. Okay. So we do this all the time in science, and I don't know why. Sometimes, when you're teaching, you're concentrating on the teaching and also, and then you get flustered, and then you're like, oh my God, now I'm in deep doo doo. So anyway, but here's the equation that we're dealing with: d sine theta. This is the bright fringe equation equals, since it's y2, we've got 2. Lambda 2, 1. Okay. Oh, 2 lambda 1. Right. 2 times lambda 1. All right. Well, let's change this. And they said, okay, you could do this. D tangent theta, that's close enough, is equal to 2 lambda 1. All right, fine. And then we know that it's D, and we know that the tangent then is y2, 1 over L, which is equal to 2 lambda 1. Well, so in the next lambda 1, why did I make that pi? I don't know. Lambda 1. So in the next one, you go, all right, well, that's no big deal. So we've got that. I got two unknowns. I can't find D. Because I thought it was one of those ones where they gave us enough information where we had to find D, and then we could plug into the next one. That's one way. That's like the easy one. The one that's a little bit more difficult is when they say, no, you got two unknowns here. Now, let's look at what we have in, so let's look at the second situation. I don't know y2, or y22, so so this is y21. So, but I do know this. I know that D, y22 over L is equal to 2 times lambda 2. Well, let's do this. Watch what happens. Watch what happens when I go, let me solve for D in this one, let me solve D in terms of L. So if I go over here and I go, well, D is equal to 2 lambda 1 times L over y21. Okay, a little algebra there. Multiply the L by both sides, divide, and I solve for D. Okay, so now I know what D is. Well, let's plug this value in here. We do this stuff all the time. So we go 2 pi 1 over L times L, not over L, times L, 2 pi 1 times L over y21 times y22 over L is equal to 2 times lambda 2. Well, we know these two guys. Well, looky here. This is so cool. Look what happens here. And we're trying to solve for y22. But look what happens here. Bang, bang. This is known. This is known. Oh, looky here. Bang, bang. That cancels too. So we wind up with a very simple algebra problem. Y22 then is equal to lambda 2 over lambda 1, lambda 2 over lambda 1 times y21. I got numbers for all this stuff, and that's what's left. Don't believe me? All right. Be that way. Looky here. Watch this. Hold on a second. This is probably going to be way too long now that I've got to screw with my kit and try and find my damn calculator, but here we go. All right. Okay, so our numbers here, what were our numbers? Y21 was equal to 0.152, L1 is 425. What was lambda 2? Lambda 2 is 571 nanometers. Now the nice thing about this, so I've filled in all that information. Now so I've got 571 divided by 425. Now the nanometers cancel, and times y21, which I know. So let's do that. So I'll take lambda 2, which was 571, divided by lambda 1, which is 425. It's 1.34 times 0.0152. Bang. 0.202421, yada, yada, yada. 0.020421. Oh, then after that part, it goes downhill. We differ because they want you to go ahead and use the tangent. You don't need to use the tangent when the angles are this freaking small. All right. Good deal.